So profiling on Aurora, right? So Aurora has several profiling tools from Intel and HPC community. So, and each tool has different features. So depending on what you want, you need to choose which profile you want to use. So in this getting started material, we are going to talk about the four tools: iProf, VTune, Advisor, and APS. And we also have additional other profilers, for example, HP's Toolkit and TAOs are available, but we are not talk about that today. Again, common part you need to get the interactive job mode. And the first profiler I would like to introduce is a lightweight tracing tool called iProp from TAPI module. So the the way to use it is very simple. You just need to load the TAPI module, and then you can use iProp. And how to use iProp? You can just put iProp at the beginning of your command line, and then you just run your application here. This is for the serial execution. For MPI execution, you need to run the MPI wrapper, MPI run dash n number of MPI rank, and then PPN, etc. Whatever the MPI argument. And then before your application, you can just put the iProp before your application. And then iProp will trace your kernel information. So this is a very lightweight tool. So at the early science mode of Aurora, many developers enjoyed using this iProp tool. So this is very lightweight and provide very critical information about your kernel performance. Sometimes you may want to have a little bit more details with the hardware metrics and some additional information. So for that purpose, I think Intel VTune could be a good profiler to get the in-depth kernel profiling or source line profiling. So in general, in order to use VTune, you don't have to rebuild your application. You can just use any application built with the high-level optimization. So if you use that without rebuilding your application, you will get the performance data per kernel based. So you will see which kernel is a hot kernel and which kernel spend a lot of high utilization, low utilization, etc. Right? But sometimes your kernel has a lot of lines. For example, 1,000 lines of kernel. It's not usual, but sometimes you may have it, right? In that case, you already know this kernel is most time-consuming kernel in your application, but you want to know which line of this kernel spend most of time, something like that. So we call that is a source level in kernel profiling. So for those profiling, you need to rebuild your application with the symbols. So easiest way to build your application with the symbols is -g, but sometimes the -g require all the symbol for even for the debugger. So, but your profiler does not require that much information. So if you don't like to use -g because of overhead, you may use this another symbol, -gf debug info for profiling and -g line table only. So in these two flags, you just provide the a little bit less debug symbol just required for the debugger, the profiler. Okay, so you may rebuild your application with this flag or -g for the source level in kernel profiling. But in practice, the kernel level profiling is also good enough. So for that purpose, you don't have to rebuild your application. Your one API module already have VTune, but at the moment, the VTune from the default one API module is a little bit outdated and it has a little bit bug. So we want to have latest VTune on Aurora. So in order to activate the latest VTune, you can just do the source and this line, and then you can see the VTune version 25.0.0 version. Default one is 24.2.0 version, okay? So just the source that, and then use this VTune. And VTune has so many features. So you probably use VTune on CPU side. There are so many features, right? Even on GPU, we have a lot of features. So HPC performance characterization could be used to understand what is the CPU utilization, GPU utilization together. And GPU off-road analysis could be useful to understand what is your off-road tax. So for example, host device transfer time, execution time, and device host transfer time. If you want to see more accurate analysis on the GPU kernel, you need to use a GPU compute hotspot analysis. So you can see GPU, the hierarchy diagram, and what kind of traffic happen inside of the GPU device, some component in the GPU device, okay? And also you can see the timeline view and then see which kernel spend how much bandwidth you use, something like that, right? This kind of information can be provided. And again, you have gigantic big kernels and you want to see which line costs most of the time. You can do source level profiling using the instruction count here, or some cycle count here, or some memory latency analysis here, okay? So Bitune, there are several ways to post-process Bitune data, and our recommended way is using Bitune web server mode, okay? So before we start, on your local system, if you have these three lines on your SSH config file, everything become much better, okay? So let me go to my terminal here, and then let's see. So if I see my SSH config file, I have these three lines: host, asterisk asf.nl.gov, and control master and path. So if you copy these three lines on your .ssh and config file, once you establish your connection to Aurora, for example, here I already, one of my terminals on the Aurora login 9, right? So and then if I just connect SSH jcloud login.aurora.asf.nl.gov, I don't need to type my Aurora credential because it reuse already established connection. So the advantage of using this connection is you can get the same login node. Otherwise, you may grab another random login node. So for Bitune, in order to use Bitune backend, Bitune web server mode, you have to establish SSH port forwarding. So for that, you need to source this one, and then you need to run the Bitune backend command. And the Bitune backend command will print out some the IP address with the port number. So using that port number, you have to reestablish your connection with another terminal. So I will show you the example later. So after establish that, you can use this IP address and the port number to see to use Bitune web server mode on your Firefox browser. Okay, so this is kind of a little bit a couple more steps required, but once you establish, everything will be very straightforward. Okay, so I will show you the practice a little later. And then another tool I would like to mention is Advisor. So these days, roofline analysis is pretty popular. NVIDIA GPU provided, AMD GPU provided, so Intel also provide that. So for that aspect, Advisor could be a good tool to see the roofline model. So Advisor is already included in the one API module. So you can just run the Advisor from the module. So advisor required to run your application twice to collect all required data for the roofline model. So for that, first of all, you need to run with advisor for the survey analysis. This is to collect your kernel timing and the hardware metric data. And then you need to run your application again with the trip count analysis to count your flops using the binary instrumentation tool GTPin. So you need to run twice. And once you're done, you need to run the report all. Then advisor will generate some HTML file we call the fed HTML with some GUI interface. And then you can see this kind of the window. Okay. So yeah, we can do it together a little bit later. And then the last tool I would like to introduce is Intel IPS. So Bitune and Advisor provide very in-depth analysis data, but at scale, they produce too much data. So it may distort your performance characteristic. So we need some lightweight tool provide to get the accumulated aggregated view of the application performance at scale. For this aspect, Intel provide APS tool. So APS already included in the VTune, so you can just source latest VTune like you did for the VTune, and then run your application with the APS. So MPI and MPI argument, and then you need to add APS -R and the result folder, and you'll run your application. So once you're done, you can type the APS result report and then the directory, and you can see this kind of HTML file. And then you can just download it and see this HTML file on your laptop. So this is overview of 4 tools. And we have a simple example. So before we move on, do you have any question about profilers? Okay, hearing none. So let me show you the example. Okay, so first of all, let me stop the debugger. Okay, and then we need to disable the debugging mode because we used the debug mode here, right? So I will unset this GT enable program debugging environment variable, and also I run the MPI-N1 and helper u toggle and 0. So now the compute node is non-debugging mode. Then I just run it without the debugger. H comp 0 p. You can see uh, this executable is running faster than the underscore debugger, right? So first of all, in order to run the iprop, we need to do the module load happy, and then you can see the iprop is available here. So in my previous MPI command line, I will just add iprop just before my executable, and then you will see iprop will trace the kernels of your application. Yeah, there's some latency today, so let's give some time. Okay, okay, now it's running. So you can see the standard output from the application, and then the TAPI trace location is here, and it shows what is trace data here, right? So it provides MPI tracing data, OpenMP tracing data, level 0, and you can see the device profiling. So CompGeo is device kernel we use, so you can see the CompGeo, how much time used, and the mean, max, and the average, etc. Right? So this is easy to check the kernel timing, and the next example is Bitune analysis. So for that, you need to activate latest Bitune first. So I will just copy source here, and then Bitune. If you check the Bitune version, you can see the 25.0.0 version. And then again, go back to your MPI executable MPI line. So instead of iprop, I will just use Bitune dash collect GPU hotspot dash all Bitune result GPU hotspot. Okay. So if you run it, you run your application with the BTune for the GPU hotspot analysis. It'll take some time. So while we are waiting, let's open another terminal here. So this is my login node, and then I'm already on the Rooster, Flare, project, LCF, and JQuack, which is my user directory in the project folder. And then let me source the BTune again here. So BTune version is here. So I just want to establish the BTune web server mode. So I see the BTune version is 25.0. And then you can type the BTune backend and data directory equal. I will just use the current folder pwd, and I will just reset passphrase. Reset passphrase is not required for you, so I just wanna once you establish, you don't need to type the passphrase, but I just wanna show what happened at the very first time. Okay, so if you run the Beacon backend data directory in PWD, you will see this kind of Beacon profile GUI is accessible through the HTTPS 127.0.0.1 and colon and some port number. Port number is assigned automatically by your Beacon backend. And then what you need to do is you need to open new terminal here, and you need to do the SSH-L to establish SSH port forwarding. And you just copy 127.0.0.1 and colon this port number. Just copy that and paste it after dash L, paste it twice with with colon and run it. So now you established this SSH port forwarding, right? And then what you need to do is you just copy from HTTPS to the end of the token here. Okay, just copy it. And then I open the Firefox browser, just copy paste it here. So if you enter, you will want, so we just advance and accept the risk and continue. And then you will see the BTune. Oh, before that, you need to set passphrase. So I will just set something. So this is just asked very first time, and next time you won't be asked, okay? So once you set up the passphrase, you will see this BTune GUI interface. So ISF beginner guide, and then go to Aurora, example, tools example, and then BTune result here, right? So let's see the execution is done or not. Okay, so BTune execution is completed here, right? BTune executing action 100% done. Now you can double click this BTune result here, and then you can see the result is popping up. Here, and you can go to graphics. Yeah, there is some a little bit latency. So let's go to the screenshot here. So once you get that, you can click that, and then you can see the summary and click the graph, and you can choose a memory hierarchy diagram, and you can see this traffics between the component. And if you click the platform, you can see also time series. You can zoom in the time series to see what happened at specific time frame, okay? So this is how to establish between web server mode. It's loading now. So yeah, I'm out of time. So let me wrap it up, okay? So this is how to establish that. And then we have two more examples with the advisor and APS. I don't think we have enough time to run the case, but in both cases, you don't have to establish any between backend type the connection. They just generate the HTML file. You can just download the HTML file and then see what happened, okay? So in the GitHub repository, we already have the example here. So if you go to 02 tools, you can see the rootline underscore or HTML file. You can open it up. So once you run the advisor, you can see this kind of summary page. You can go to GPU region, and if you double click, what is your bottleneck, etc. This is a advisor result, and you also have the APS report as an example. So if you click that, you can see how much time used by CPU, GPU, what is the GPU stack utilization. If you hover your tool tips, you can see what is MPI time, min, max, etc. Right? So this is kind of a quick overview of advisor and APS result.